Hi, we're Team Dyna Dragon, and this is our stock prediction model. Our team is made of 4 members, myself, Zihao, Harold, and Stamatios. First, some motivation. The trading rule says that we can buy call or put option at $26. This will buy us 100 lots. This means that the price movement has to be correct and it has to be at least 26 cents for us to break even. So we draw some histograms of the price movements. If we take one data point every 5 minutes and take our lead time to be 15 minutes, 10% of the time, our training example will have a price movement of larger than 26 cents. If we take a 30 minutes lead time, then increase to 19%. Okay. However, it may be difficult to predict a 30 minutes lead time. So we can also try a COMSUM filter. This will also give us a lead time of approximately 15 minutes. And the sampling is also roughly approximately at 5-minute level. And this will give us so 26%. So this will increase the chance that the price movement will be larger than 26 cents. So here's a graph of our sampling. So this is sample spaces with more activity more, and sample spaces with less activity less. And the RMSE for this scheme is 0.49. So effectively, if we count in terms of events, we are making a T+3 prediction. Okay, next for normalization. Ideally, normalization should not depend on a data set. So this will allow us to easily accommodate new data. The price series itself, open, close, high, low, do not need to be normalized as the price differences are already smaller than 1. Volume is normalized using log because there are volume spikes which increases the volume by an order of magnitude. So log is appropriate here. So secondly, fractional differentiation of the normal price series should be normalized using by dividing by 10. And also, some technical indicators are between 0 to 100, so we simply divide them by 100. Now for our network size is for the top layer is 42. The shrinkage is roughly 2/3. We're using square perceptrons. Our optimal dropout is found to be about 15%. We are using regularization and an Adam solver. The 6 features that we come to are there's actually 7 features that we come to are fractionally differentiated features at these levels. And slightly at the volume, but we slightly differentiate to try and make it more stationary. And then we can also use the skewness also turns out to be slightly useful. Now for our test predictions, there's still some very clear signs of lag, so our network isn't fully fitting the training set that well. Now for test predictions, also some signs of lag. The test loss is 0.068, which beats persistence. So as for scatter plots, our scatter plots are tightly are around the x equals to y line, which shows we are not systematically over or under predicting. So now for lag correlations, we have a training peak at 2, which is not good. We have a test peak at 0, which is a good sign. But this does not necessarily imply our results are actually good. Also, the problem with our network is that we're not actually fitting enough. So we have just found our overfitting point, which is a network of 8 layers with a shrinkage factor of about 2/3. So this is how we are continuing improving our model from here. So now for our actual prediction, the test lag is 0, but you see, as you can see, the region that we really care about is this starting portion here, which is where there's the most profit potential. The region here has little test has not much lag, but there's no profit potential here. So now for trading strategies, the logical trading strategy is to just put an order whenever we forecast a change of more than 26 cents, but however that almost never happens. So which means we have to reduce our threshold to actually make trades, okay. So as you can see here, it is able to make some sensible trades. When the price is going up, when the price is going up, it's making calls, and then when the price is going down, it's putting puts. But however, the price movements here are not large enough to make up for the cost of the call and put option, and therefore with this strategy loses money. However, we're also using 60-minute options because simply the price is as opposed to 15 minutes, also because the price movement within 15 minutes is simply not enough to make up for the cost of the option. And also the price is not mean reverting, so which means when the price goes up, it doesn't come down. So there's very little downside to using 60 minutes as opposed to 15 minutes, and it costs the same as well. Okay, thank you.